Hi students, good morning to all ma. Today we are discussing techniques for graphs. In previous video we seen breadth first search. Now we seen depth first search. Depth first search is nothing ma. It is an algorithm for what we are traversing or searching tree or a graph data structures. It is an algorithm for what we are traversing a tree or searching tree or graph data structures. Here the algorithm starts at the root node. The algorithm starts at the root node. First of all, we need to selecting some arbitrary node. What we have to select there? Arbitrary node as the root node in the case of a graph. In the case of a graph, first of all we need to selecting some arbitrary nodes as the root node. Here each branch, before we are taking a backtracking. Okay, here we need to explore as far as possible. It's so long we have to be considered each branch before a backtracking. Okay, before backtracking we have to each and every branch we have to visit. First of all we need to selecting some arbitrary nodes as the root node in the case of a graph, and we need to explore as far as possible along each branch before we are doing backtracking. So the basic idea is to depth first search is start from the root node or any arbitrary node, and if we have to mark the node, listen carefully ma, to start from the root node or any arbitrary node and mark the node, and we want to move to the adjacent unmarked nodes. Then we have to move to the adjacent unmarked nodes and continue this loop ma, until there is no unmarked adjacent nodes, until there is no unmarked adjacent nodes. Then we have to say backtrack and check for other unmarked nodes. Then if we have to do backtrack and check for other unmarked nodes and traverse or walk them, finally if we have to print the nodes in the path. Okay, this is the basic information about depth first search tree. Now we have to study about what is an algorithm. If we have to follow 3 steps in depth first search, that is algorithm. Listen carefully. Algorithm, first of all we need to create a recursive function that takes the index of node and a visited array. First of all we need to create a recursive function ma, that will takes the index of a node only and a visited array. Coming to the second step of this algorithm, if we have to mark the current node as visited and print the node. If you want to mark the current node as visited and print the node, finally the third step it should be, if we have to be traverse all the adjacent and unmarked nodes. Okay, we if you need to traverse all the adjacent in the center, adjacent in the sense adjacent in the sense, if we have to select some root node have some connected vertices, that is nothing but adjacent vertices. If we have to traverse all the adjacent vertices and unmarked nodes and call the recursive function with index of adjacent node. Okay, with the index of adjacent node, these 3 steps we have to be follow for depth first search tree algorithm. Now coming to the time complexity analysis of depth first search. Already if you know, they were big O of v plus e, in the sense where v is the number of vertices and e is the number of edges in the given graph. Okay, and coming to the space complexity, order of v, since we say an extra visited array is needed of size v, Okay, here the space complexity is big O of v, since an extra visited array is needed of size v. Here what the main aim of depth first search? Look at this, the diagram. Here how many nodes? If we have 7 nodes, in the sense size will be 7, in the sense number of nodes present in the tree. Okay, how we want to traverse the depth first search tree? Traverse through, first of all, left subtree. In the sense I have given the numbers 1, 2, 3, 4. First of all, if you need to traverse through left subtree first, then if you have to traverse through the right subtree 5, 6, 7. This is the process of depth first search tree. Okay, if we have 3 algorithm steps, first of all we need to create a recursive function that takes the index of node and we need to visit the particular array. The second step, we need to mark the current node as visited and we need to print the particular node. The third step is nothing but we need to traverse all the adjacent nodes and unmarked nodes, and if we have to be call the recursive function with index of adjacent node. Okay, and coming to the graph traversal techniques. In this graph traversal technique, already we discussed in previous class breadth first search. Now the graph traversal technique, one more is there, that is depth first search. Here the depth first search uses a stack operations. Nothing but here the depth first search uses stack. In the sense, we need to follow last in first out manner. First of all, we need to remember to get next vertex to start a search. If you need to start a search, if you get to remember the next vertex to start a search technique. Coming to the rules to be followed by depth first search, if we have some 3 rules, it must and should follow by depth first search. First of all, it has to visit adjacent unvisited vertices. Already I say you previously also. First of all, if we have to visit adjacent unvisited vertex and mark it as visited, and we need to display it as output, so we need to push it into a stack manner. Okay, and coming to the second key rule, if no adjacent vertex is found, pop up a vertex from stack. Yes, if you not push up here, if no adjacent vertex is found, if you must and should if do pop up in the sense delete a vertex from stack itself. Okay, and coming to the third rule, that is nothing but if we have to repeat rule 1 and rule 2 until the stack is empty. Until the stack becomes empty, if we have to repeat the rule 1 and rule 2. Okay, first of all, if we have to visit adjacent unvisited vertex and mark it as visited vertex and display it as output, and we need to push into a stack. And coming to the second rule, if no adjacent vertex is found, just if you need to remove a vertex from stack. Now coming to the algorithm for depth first search. Listen carefully, ma. Algorithm for depth first search, if we have to take some name depth first in open flower brace, in open flower brace depth first search of V, in the sense if you need to search the vertex here. Okay, and then if you have to label vertex V as reached, in the sense you are visiting the vertex V as reached or not. And coming to the condition for each unreached vertex is adjacent listen carefully. For each unreached vertex, we are indicating small u adjacent from small v. In the sense, for each unreached vertex u, it is very adjacent from v. And now we have to take a depth first search of u. In the sense, the vertices you have to be unreached vertex u is to be searched. Okay, this is the algorithm for DFS. Now we move to the example concept of depth first search. Okay, this is the it is a connected graph example problem for depth first search. First point, if you need to start search at vertex 1, listen carefully. If you want to label vertex 1 and do depth first search from either 2 or 4, suppose I have taken the vertex 2 is selected. Listen carefully, I have to given that 1 if we have the adjacent nodes 2, 4. Suppose I have taken the vertex 2, that's why I will draw very thickly manner. Okay, ma. Next step 2, label a second vertex and do depth first search from either 3, 5 and 6, and now I have to suppose to select 5 now I have taken the vertex 5 is selected. Now I have to draw 1 to 2 is there already, I have to connect it, and 2 to suppose I have selected 5. This will be I have to draw that line. It will be a thick manner. Okay, and coming to the third step, label vertex 5 and do DFS from either 3, 7, 9. Suppose I have taken 9 here. Look at the diagram here. 1 to 2, 2 to 5, 5 to 9. I have to draw the lines very thickly. Okay, and remaining lines are simple way. And coming to the fourth step, label vertex 9 and do DFS from either 6 or 8. Okay, or 8. Suppose I am selecting 8 here. Look at this diagram. Suppose I have to be selected 8 here. That's why 1 to 2, 2 to 5, 5 to 9, 9 to 8 I have to be drawn with a red color, and remaining colors are black color. Okay, a black simple line. Okay, and coming to the fifth step, label vertex 8 now and written to. Now we have to taking here. So before we are traversing, just we have to take here just backtracking. Already I said to you, listen carefully in first page itself only. Before backtracking, if you need to explore as far as possible along each branch before backtracking. Okay, here we need to use here backtracking concept here. First of all, I have to be label vertex 8. Listen carefully, vertex 8 and return to vertex 9. That is backtracking. So now from vertex 9, do depth first search on 6. Okay, on 6. That's why I have to return back return in the sense I have to given some double line 8. Okay, label vertex 8 and return to vertex 9 that is backtracking. That way I will given the diagram here double line manner, that is backtracking. So now from vertex 9 itself we want to perform, we want to do depth first search operation on 6. Okay, 6. Okay, label, listen carefully, label 6 vertex. Listen carefully, I will write say everything. Label 6 vertex and do depth first search from either. I have to not complete either spelling if we have to be completed. Label 6 vertex and do depth first search from either 4. 6 have to be connected 4 or 7. Okay, 4 or 7. 2, 9 already visited. That's why I don't want to take that. Label 6 vertex and do depth first search from either 4 or 7. Suppose I have to be selected 4 here. Look at the diagram here. I have to again backtracking 8 to 9 and then 9 to 6. The label vertex 6. 6 to, if you have to know 2, 9 already selected. Now I have to taken 4 and 7. Now I have to be selected 4th vertex. Okay, 4th vertex. Now we have to be visited. Label 4 vertex and listen carefully, label 4th vertex, for label vertex 4 and just return to 1 already visited. That's why label 4 vertex and just return to 6. From just return to 6. Suppose just return to 6 from 6 label vertex from 6. We want to do perform depth first search on 7. Okay, why? Because of 6 have to be connected to 9, 7. 2, 9 already be connected and remaining only one vertex 7 will be there. Now we have to taken 7. Label vertex 4 and just return to 6. From 6 itself we want to do depth first search operation on 7. Okay, now we have to take in 7 will be very dark. Okay, already I have to draw red lines. Look at the red lines. 1 to 2, 2 to 5, 5 to 9, 9 to 8. 8 will be backtracking to 9. That's why I will represent as double line and I will move 9 to 9 have be connections 5, 6. Now I have to be taken a 6 vertex. Okay, 6 will be the connections 4 to 9, 7. Now I have to be taken 4, 7. Why? Because of 2, 9 already traversed. Now I label 4th vertex and just return to 6. Next, from 6 operation we want to perform do depth first search on 7. From 6 do DFS on 7. Okay, label now I have to be label vertex 7 and just label, I have to label vertex 7 and just back and just 5, 6 will be there. 5 already visited, 6 already visited. Just back return to the 6. Next, the step 9 I am checking return to 9. Just backtrack just backtrack. 7 will goes to 5 and 6. Just backtrack. Now I am checking return to 9. Like 6 to the just backtracking to the 6. The 6 have 2 and 9. Okay, 6 have 2, 9, 4, 7. Okay, already the nodes are visited. Just I am checking return to 9. Why? Because of return to 9, and return 9 will be written to 5. 5 and 6. 6 already visited na. 5 return to 5. And the 11th step will be do depth first search operation on 5. Will have connection 2 and 3. 2 already visited, 3 is not visited. That's why we want to do some operation depth first search on 3 node. Now label vertex 3 and return to 5 again, and have to be written to 5, and we have to be written to 2. Finally, listen careful, label 3 vertex ma, and return to 5, and return to 2. Finally, if we have to be written 2 to 1. Okay, this is the way. 1 to 2, 2 to 2 to 5, 5 to 9, 9 to 8, and then 8 to 9 backtracking. 9 to 6 will be there. Okay, 6 will go listen carefully ma. 6 will be taken from suppose 6 vertex, and do depth of search from either 4 or 7 is there. Suppose I have to take 4 here. Okay, 6 label vertex 4, and just we have to be written 6. Just we have to return 6 and do DFS on 7th node. Okay, from 6 we have to do DFS on 7, label vertex 7, and just backtracking to the 6th. Just I have to backtracking, double line will be give 6, and I am checking return to 9, and I am checking return to 9, and that I will give double lines, and we have to be written to 5. That's why I have to give in double lines, and we have to do DFS operation on node 3 vertex 3. That's why I will give double quotation, and if you have to be written to 5 already is there, and we have to be written to 2 double line quotation. Finally, if you have to written to 1 double line quotation. Okay, this is the concept of depth first search. If you have any doubts, can you please ask me. Thank you ma, one and all.